Hi, good morning. In the last session, we have discussed LVW is a vector space. Now, what it mean by LVW? LVW means the space of all linear transformation from V into W. Now, in this session, we are going to prove one theorem. Okay, let V be an n-dimensional vector space. N-dimensional. We say n-dimensional vector space over the field F, and let W be an m-dimensional vector space over F. Then the space LVW is finite dimensional and has dimension Mn. This is one of the most important result. Okay, we have to prove dimension of LVW is Mn. V is of dimension n and W is of dimension n. Okay, now moving to the proof. Listen carefully. We have given given V is of dimension n and W is of dimension m. Okay, let B equal to alpha 1, alpha 2, etc. alpha n is an ordered basis for V. Clear? Listen carefully. And B dash is equal to beta 1, beta 2, etc. beta m is an ordered basis for W. Clear? We are choosing two bases, one for V and another for W. Clear? Okay. Now for each pair of integers P and Q, for 1 less than or equal to P less than or equal to M and 1 less than or equal to Q less than or equal to M, we define a linear transformation EPQ. Okay, from V into W by E PQ of alpha I is equal to 0 if I not equal to I not equal to Q, and beta P if I equal to Q. Okay, this is our definition. Okay, why this is defined for alpha I? As alpha is our ordered basis, once we define this for a basis element, we can clearly extend this to other elements. For example, if some alpha belongs to V and we know the definition for EPQ for alpha I, then alpha you can write as this is alpha 1, alpha 2, etc. Alpha n is a basis. Alpha you can write as C1 alpha 1 plus C2 alpha 2 plus etc. plus Cn alpha n. Okay, and what is EPQ of alpha? EPQ of alpha equal to C1 EPQ of alpha 1 plus etc. So we have this result. Okay, so we can apply this result here. Then finally we get the value of EPQ of alpha. Therefore, these EPQ are linear transformation from V into W. Now, how many elements are there in EPQ? EPQ 1 less than or equal to P less than or equal to M. 1 less than or equal to Q less than or equal to N. Then how many numbers are there? First one you can write as E1Q. Q varies from 1 to 10. That means E11, E12, etc. E1N. Okay. Now, if P equal to 2, E21, E22, etc., E2n. So, total we have as P varies from 1 to etc. m and Q varies from 1 to etc. n. The total numbers of EPQ is Mn. Okay. Therefore, we have this set. This collection EPQ is the collection of all Mn linear transformation. Okay. So, now what is EPQ? EPQ of alpha is alpha I is defined like this. Okay, 0 if I not equal to Q, beta P if I equal to Q. Now, if you look at this delta Ij, what is the value of delta Ij? 0 if I not equal to J, 1 if I equal to J. Therefore, if it's delta, what is IQ? Delta IQ. This 1 if I not equal to Q, and this is equal to I equal to Q, 1. Okay, then if you multiply this with beta P, we get beta P here. Okay, therefore this you can write as delta IQ beta P. Okay, so EPQ of alpha is equal to EPQ of alpha is equal to delta IQ beta P. Clear? So we have Mn linear transformation EPQ. Okay, defined like this. Now we have one result, one theorem. Theorem 1. There is unique linear transformation from V into W satisfying the condition, that is T alpha j equal to, I think, beta j. So here we are defining EPQ of alpha equal to this element. Therefore there exists a unique linear transformation. Okay. So now we are claiming this Mn transformation. We have Mn transformation EPQ form a basis for LVW. Okay, that means dimension of LVW is equal to Mn. Okay, we have Mn transformation because EPQ 1 less than or equal to P less than or equal to M. Similarly, 1 less than or equal to Q less than or equal to M. Therefore, total number is Mn. Okay, so first we are going to prove EPK spans LVW. For proving EPQ spans LVW, it is enough to prove if you take any linear transformation from V into W, then this is a linear combination of, we can write this as a linear combination of EPQ. Okay. Now, if you look at T is any linear transformation from V into W. T alpha j clearly belongs to W. Okay, as B dash is an ordered basis for W. Okay, there is a unique representation for T alpha j. Okay, clear? That is B dash is an ordered basis. Okay, so if a basis is an ordered basis, then there is a unique representation for any alpha belongs to that set. Now, now what is the meaning of a unique representation? That coefficient is unique. Okay, so that is coordinate vector is unique. Okay, so let A1j, A2j, etc., AMJ be coordinates of T alpha j to the relative to the ordered basis B dash. Okay, then T alpha j you can write as, let it be this one, coordinate be this one. Then you can write T alpha j as linear combination of elements in B dash. Now, the set B dash is actually beta 1, beta 2, etc. beta m. Okay. So, T alpha j you can write as sigma p varies from 1 to m apj beta p. Now, we have to prove T as a linear combination of EPK. Okay. That is, we have to prove this one. T is equal to, how many numbers are there? EPQ, Mn numbers. Therefore, sigma P equal to 110, sigma Q equal to 110. Suppose this is APQ into EPQ. Okay. So, we are going to prove this one. T equal to this one. Okay. We have T alpha j equal to this one, and we have to prove T equal to this one. Okay. For this, we assume that the right hand side, let it be U, and we have to prove T equal to U. For proving T equal to U, what we have to prove? We have to prove T alpha equal to U alpha, or we have to prove T of alpha j equal to U of alpha j, because alpha j's are bases. Okay. So let U be the linear transformation. This is the right hand side. U is the right hand side of V. Here we want to show this. Okay. So U equal to this one. Now what is U of alpha j? U of alpha j is this of alpha j. Okay. And which is equal to taking alpha j inside EPQ of alpha j. Now by definition EPQ of alpha j is delta I j q beta p. APQ. Okay. So this is varying. This sum is varying. First you take Q equal to 1. Then this becomes J1 AP1. J1 is 0. And then Q equal to 2. AJ2, AJ3, etc. Finally there may comes AJJ. At that time this value is 1. And this become APJ. Okay. Beta P. Because J is very, Q is very, when Q is equal to J, this become 1 and this become APJ. Okay. Therefore, this is equal to sigma P equal to 1 to APJ beta P. Therefore, if you look at the back, T alpha j is APJ beta P. Therefore, this is equal to T alpha j. Okay. Once again, we have already T alpha j equal to sigma P equal to 1 to m APJ beta P. Here also we have sigma P equal to 1 to m APJ beta P. Therefore, this is equal to T alpha j. Thus, we get U alpha j equal to T alpha j for every j. This implies U of alpha equal to T of alpha for every alpha belongs to V. This implies U equal to T. But we have U equal to sigma P, sigma Q, APQ, EPQ. Therefore, T is also equal to this. Okay. Therefore, if you take any linear transformation T from LVW, that is a linear combination of EPQ. Now we have to prove EPQ is linearly independent. So we are considering this sum is equal to 0. Why? We have to prove linear sum, we have to assume linear combination of this one 0. That is sum C1 E1Q plus E2 E2Q etc. plus CEM CEN EPQ. I think CM EPQ EMQ plus again T1 etc. like this. For CAs we are replacing APQ. Okay, so sigma P equal to 1 to m, sigma Q equal to 1 to m, this equal to 0. This equal to 0 implies this of alpha j equal to 0 of alpha j. Now this of alpha j you can write as this of alpha j equal to this one equal to 0. That means this value is actually equal to delta ij beta p. Therefore this is equal to 0. Okay, so if q varies, okay, and that's equal to if q varies means here this become ij, and as q varies from 1 to m. Okay, this become if this become I think this is delta iq. This is delta iq. So q varies. So this become 1 if q equal to this is delta jq. Okay, delta jq. So this become apj beta p. Clear? This is actually sigma p varies from 1 to m, sigma q varies from 1 to n, apq delta jq beta p. Okay, so this become q equal to 1 to etc. This become 1 if q equal to j. Therefore this become sigma p equal to 1 to m a p j. This is delta jj, that's equal to 1 into beta p, and this equal to 0. But beta 1, beta 2, etc. are linearly independent. Therefore, this equal to 0 means A P J equal to 0 for every P and for every J. Therefore, EPQ is linearly independent. Therefore, these vectors EPQ 1 less than or equal to P less than or equal to M, and 1 less than or equal to Q less than or equal to N are linearly independent and spans W. Therefore, they form a basis for, actually this spans LVW. Okay, therefore they form a basis and basis contains M and LMS. Therefore dimension of LVW is equal to M and. Okay, hope everything is clear. We will continue in our next class.